In this video series, we will begin discussing proportional reasoning, looking at unit rates, differences between ratios and rates, looking at percents, tax, discount, all of those topics that really are incorporated with proportional reasoning. So we're going to start with rates and unit rates and try to understand the difference with some of these and what is a ratio. Well, we want to say that that is a comparison. It's a comparison between two amounts. And sometimes we can write that using division. But what it's not is it's not additive, or it doesn't use differences, which means we are not adding or subtracting when we're looking at proportional reasoning. Now, we will notice that there is we can look at how tables will increase by adding. In a way, we can look at how the table is increasing, how the X values are increasing or the Y values are increasing, and we can go up and down the table. So we could add or we could subtract. But when we are actually trying to create different ratio tables, we do that with an idea of some sort of multiplicative idea. So when we say a ratio can take the form of the following, well, it can take the form of a fraction in the fraction form, like 5/8. And so when we're comparing something, we would end up, this 5 of some amount to 8 of some amount. We can use a colon to represent that. We could say 5 to 8. Or we can use words to represent that. We would say 5 to 8. So those are different ways that you can write ratios. This next one, just using the image to determine the ratios that compare soccer balls to tennis balls. Now notice we have a total of different sports balls here, but we're not asking about the total. We're looking at tennis balls compared to soccer balls, but then more importantly, look at the wording, determine the ratio that compares soccer balls to tennis balls. So we're going to start with soccer balls. So I need to know how many. Okay, so there's 1, 2, 3, 4, 5, 6, 7, there's 8. So there would be 8 soccer balls, and then how many tennis balls? So it'd be 1, 2, 3, 4, 5, 6. So if we wanted to write that in 3 different ways, comparing soccer balls to tennis balls, we could say 8 to 6. And that is not simplified. So if we wanted to simplify that, we could say the same as 4 to 3. And notice that similarity of equality is not done by sums or differences. That's done by multiplying or adding, or multiplying or dividing. So 8 divided by 2, 6 divided by 2 would get us to say 4/3, or 4:3, or 4:2:3. So we always want to try to simplify our ratios as much as possible. Now, if I would have said tennis balls to soccer balls, then we would have reversed those numbers. We would have said 3 to 4, or 3:4, or 3:to 4 in our word form. The next one is we're using the image to determine the ratio that compares apple pie's top to cheesecakes, which is the bottom. Well, there's 2 apple pies to 3 cheesecakes. So if we wanted to write the fraction, we would write 2 divided by 3, 2:3, 2 to 3. And then again, if I had cheesecakes first, apple pie second in my wording, then that would be 3 to 2 in the representation. So you also want to look at what you're comparing and how it's worded in the given information. Another, there's different types of ratios. Okay, the soccer ball to tennis ball problem was a part to part. We were comparing soccer balls to tennis balls. So there is a part to part, and there's a part to whole. And the part to part we call ratios because we're comparing one amount to another amount. But then all fractions are going to be considered that part to whole in regard to a whole. So the part to part ratio is when you're comparing one amount of something to another amount of something. The 2 apple pies to 3 cheesecakes. The part to whole ratio is when you're comparing that amount of something to the whole amount of things available. So there were 2 apple pies, there was 3 cheesecakes. So 2 to 3 would be the apple pie to cheesecake ratio. But if we were talking about apple pies to total, then that would be 2 to 5 because there would be 5 total cakes. So remember, ratios can be written as fractions, but they're not fractions because ratios can be written as part to part or part to whole of 2 different quantities. Therefore, fractions are always part to whole of 2 quantities. When ratios are scaled up, when they're scaled up or scaled down, we're especially when we say scale them down, we're looking at the smallest comparison possible. Okay, so we want to say that the ratio is said to be in simplest form. We're not really using the word reduced here because many times students get the idea that reduced means a smaller value. All you're doing is creating an equivalent fraction, that's all. But we would want to say that it's in its simplest form in regard to factors. So let's determine the simplest form for the ratio that compares the number of red candies to the number of brown candies. So there's 8 pieces that are of red candies and there's 12 pieces of brown candies. So if I want simplest form, I want you to think of it as, well, 8 can be 2 multiplied by 4, and 12 can be 3 multiplied by 4. So we're looking for common factors that we can divide out. And when we divide those out, we're left with 2 to 3. So 2 pieces of red candy to 3 pieces of brown candy is the same as 8 to 12. They're just equivalent fractions. It's as if you had, on number 11, if you had 8 hot dog buns and 10 hot dogs. What would that comparison look like if you bought 2 of each? Well, now that would look like 16 hot dog buns to 20 hot dogs. If you wanted 3 of each, now we're talking 24 hot dog buns to 30 hot dogs. What if it was 4 of each? You see the pattern. What's happening is we're just multiplying by 2 or 3 and 4. So we're multiplying both numbers by that amount. So 32 hot dog buns to 40 hot dogs. So we're scaling it up by a multiplier. And when we scale it down, remember we're looking at, in yellow here, we're looking at common factors that we can divide out. So a rate, we talked about ratios. Now let's look at rates. Rates is just a comparison of 2 different units and how they relate to each other. So when we say Rita can type 40 words in 2 minutes, typically our units are words per minute. That's what we would be comparing. Bobby's car can drive 200 miles on 18 gallons. Our units are miles per gallon. So we may have the number 218, but we're dealing with miles and gallons. So we're dealing with 2 different types of measurements. two quantities, two different types of measurements brings in the idea of a rate. 18 ounces of cereal for $3.29. Typically, that's going to be how much per ounce? Or how May throws a football 70 feet in 4 seconds. Okay, that would be 70 feet. Well, it would be feet per second. So those would be your different units. A rate can, again, expressed in such a way that it reveals how much of the first quantity is for just one unit of another, okay? So when we're dealing with unit rates, okay, a rate expressed that it reveals how much of that first quantity that we're dealing with there is for just one unit of another. So that's our difference. Rates, again, rates we're dealing with two different units. Well, the unit rate is when we see that we have one unit of another. Typically, we'd like to see that in the denominator. We would like to see how many words per 1 minute, how many miles per 1 gallon, how many dollars per 1 ounce, or how much money per 1 ounce. So unit rates are easily calculated. Once a rate has been created, divide both of the terms of the rate by the top term in regard to the fraction in the numbers that you're comparing. So if you earned $120 in 8 hours, okay, this idea of how we're calculating it is we're going to divide both terms by 120. 120 divided by 8. I said that wrong. So that's by the bottom term. I thought it one way and I said it another way. So I'll back up. Unit rates are calculated. Once a unit rate's been created, divide both of the terms by the rate by the bottom term. So when you have $120 in 8 hours, you're trying to figure out what that would be in 1 hour. So we would take, if you were just using division with this longhand, you could ask the students to divide. How many times will 8 divide 120? And we would see that that would be 15 times. So that would be $15 per 1 hour. Now, if you're going to type this in to the calculator, you would type in 120 first and 8 second. That's exactly how you would type it in, and what you would see is 15. So $15 per 1 hour would be your unit rate. Next, Randy needed gas for his lawnmower before he started cutting grass. To deliver 15 gallons of gasoline, it took gas pump 3 minutes. Calculate the unit rate of gallons per minute. So what you're dealing with is you want 15 gallons in 3 minutes. So it just wants you to calculate the unit rate of gallons per minute. So that would divide 15 divided by the bottom term. So that would be 5 gallons per 1 minute. You know you've got it into a unit rate when you can calculate that denominator to be 1. Babysitter has 32 pieces of candy. So we've got candy, 8 children. Okay. How much would this be per child? So 32 divided by 8, we'd have 4 pieces of candy per 1 child. That is your unit rate. Bakery's having a sale and it's selling 3 cakes for $12. So I would say $12 for 3 cakes. Calculate the unit rate. That would be $4 per 1 cake. Again, you're trying to get everything down to one amount when you're dealing with unit rates. Here, your local grocery store is having a special on vitamin water. They're selling a 12-pack of 20-ounce bottles for $17.50. Okay, so I'm just going to title this over here. This is your 20-ounce scenario. $17.50 divided by 12. So when you do that division, you're going to get about $1.45, 46 per what? Per 1 bottle, because you're buying a 12-pack for $17.50. When you divide that by 12, that's 12-pack or 12 bottles. You're trying to get it down to 1. So it's $1.46 a bottle. The 32-ounce bottles are on sale for $1.50. Okay, so we have the 32-ounce for $1.50 per 1 bottle. So it's about a 4-cent difference. Mathematically, we can see that one's different than the other, but typically comes down to money and price. 4 cents may be a wash. You know, when we really get down to it, really comes down to preference and whatnot. But here you've got $1.50 for 1 bottle, and you're going to buy 8 of those. So if you $1.50 multiplied by 8, and you've got $12 you're going to spend, I'd rather buy 8 of the 32-ounce bottles, because that's going to give me $12 for 8 bottles that are 32 ounce. Here, it would be $17.50 for 12 bottles with the 20 ounce. So I actually get, you know, I'm spending less, I'm getting more amount, but a big deal of it is that we compared, okay? So when you compared here, you thought, well, the 32 ounce is more, but I'm also buying less, okay? Should you buy a 12-pack of 12-ounce bottles or 8 32-ounce bottles for? So if you're looking at total price there, of course, you're going to spend less. But then notice that getting it down to the unit rates they were just a little off. 20 ounce was a little less, but overall, when you're dealing with 12 versus 8, you can see good problem for kids to look. You know, then it's going to bring in the fact, all right, do I allow them to use a calculator with certain things? I think what you're trying to teach is, in this case, you're trying to have discussions about proportional reasoning. So if it helps them use a calculator to compute, to then talk about the answer, that's one thing. If you want them, you just want to see, do they still have the skill, or do they have the skill of dividing decimals? Well, then that's a different question. So in this case, you're asking them questions about proportional reasoning, or are you asking them questions about dividing decimals? So you kind of have to think about what your goal is in your assessment. The next one, which size should I purchase so that I pay less per pound? So I am paying per pound. That's the idea there. So there's $9 per $6.75, 6 3/4 pounds. And then here I've got $18.50 and 14 8/10 pounds. Well, the $9 divided by $6 3/4 pounds is about $1.33 per 1 pound. Okay, so there's your unit rate for this natural fertilizer, but you got a coupon. And then here, you're dealing with the $18.50 divided by 14, was it 14 and 8/10 pounds is $1.25 per 1 pound. So, you know, which one should I purchase so that I can pay less per pound? Well, you're actually going to pay less per pound here because the unit rate is a good 8 cents different. So getting it down to comparing the unit rates is very, very helpful with comparing prices. You could also look again, all right, which one has the better deal? So we're going to take $4.50. We're going to divide it by 12 ounces. So I'm trying to figure out how many dollars per 1 ounce. So the $4.50 divided by 12 is, well, if I round it, it's about 38 cents per ounce. Item B is $2.50, and I get 7 3/4 ounces. And that's about 32 cents per 1 ounce. So 6 cents difference. So mathematically, we would see that that one is cheaper. You're spending less per ounce. Dealing with equivalent ratios, we're going to look at equivalent ratios, ratio tables, and then looking at proportionality of graphs for this first video. So Ellie's in charge of planning the food for the team party after the walkathon. She's found a great deal at a local sub shop, sells huge party subs that can split for people to share. For every 3 huge party subs she purchased, she'll get 12 bags of chips. So let's look at creating a ratio table. So in this case, you know that it's 3 subs, 12 bags of chips. If we can think about scaling up and scaling down, it's helpful to know what the unit rate would be. So this is 12 bags of chips divided by the 3 subs, which would be 4 bags of chips for 1 sub. So what would it be for 2? Well, that would have to be 8. Now, you can start thinking about, well, if I want to scale this, okay, well, this is 4 to 1 is that unit rate. Well, 4 times 2 is 8, and 1 times 2 is 2. Or I could think 4 times what is 12? Well, that would be multiplying by 3. Well, 1 multiplied by 3 is 3. Or I could say, what would it be for 4? Well, I can also think too that I need to have a unit rate that's going to be equivalent to 4 to 1. So that would have to be 16, because 16 divided by 4 would be 4 to 1. So what if I wanted 5? What if I wanted 10? What if I wanted 15? Okay, so let's still take that idea of 4 to 1. This would be 20, because 20 divided by 5 would still be 4 to 1. Okay, this would be 40. 4 multiplied by what gets you 40? That would have to be 10. 1 multiplied by 10 gives you 10. So 1 multiplied by what gives me 15? Well, 15 multiplied by 4 gives me 60. So that's how we can, here's what we knew originally, is that was all we knew. So we scaled the table down and simplified it to find the unit rate in green. And then once we found the unit rate, we could find any of them by scaling it up. Again, we know that using this of acres to pine trees, okay? So we know that we've got 150 pine trees to 10 acres, and that would be 15. We've got 150, so that would be 15 to what? 15 to 1 acre, because this was 10 acres, this was 150 pine trees, so we've got 15 pine trees per 1 acre. So we found our unit rate right here. So knowing that, we could multiply. 1 times what gives me 3? Well, that would be 3, so 15 times 3, that would give me 45. And again, 45 divided by 3, just write that neater, that would be 45. So if you looked at that ratio, 45 divided by 3, that's the same as 15 to 1, which is the same as 75 to 5, 150 to 10. So how could I use my unit rate to figure out 15? Well, 1 multiplied by 15 is 15. 15 multiplied by the same amount of 15 gives me what, 225? So that could, you can use the unit rate to figure that. 750 divided by 50, that's back to 150. And then 1 multiplied by 200. Take 15, multiply it by 200, and you have 3,000. So 3,000 divided by 200, you're back to that 15 to 1 unit rate. So all of these are proportional, and they're all increasing by the same amount. Notice we multiplied by the same amount each time. But the start of it is that we went back and found what the unit rate was, which was 15 pine trees to 1 acre. All right, so this last part of this video series is we want to look at graphing and proportionality. So Ellen's family is purchasing their admission tickets for the zoo. Adult tickets are $15 each. Children's tickets are $9 each. So there's many ways to represent how much the family will pay for tickets. Let's just look at the children's tickets for right now. So this verbal description you see right here is the child's price. So the verbal description would be, it is $9 per child. Now, what would be the ratio or the unit rate? Well, that unit rate would be $9 per 1 child. What about a ratio table? Well, if we know that it's 1 ticket, especially for the children, and it's $9, then what would it be for 2? Well, that would be 18. What would it be for 3? Well, that would be 27. See, each of these have a simplified ratio to the 9 to 1. 18 divided by 2, 9 to 1. 27 divided by 3, 9 to 1. And we could keep going. That would just be 36 to 4. Notice 36 divided by 4 is 9. And then 45 divided by 5 is 9. So these are all equivalent ratios that all equal 9 to 1. But when you graph those, notice that 1 ticket's $9, 2 tickets 18, 3 tickets is 27, and notice that at 0, 0, okay, this actually goes through the ordered pair 0, 0, and it has a constant rate of change. But in this case, we're not talking about rise and run, so to speak, not in this grade level. We're really talking about proportionality. Is this proportional? Yes, 9 to 1 is the same as 18 to 2, 27 to 3, 36 to 4. Now, we wouldn't necessarily draw a line between those because for one reason is we can't really have a half a ticket or 1.5 tickets. So that's why this is more discrete data. So this is not something that we would necessarily want to draw the line because number of tickets is not something that we can find intervals. Typically, we're only looking for a whole amount. But if it goes through the origin and it has a constant rate of change, then we have a proportional relationship. So your last question, and one of the last questions, how do we determine if a graph or a table represents a proportional relationship? So when you're looking at the graph and the table, so let's say X and Y, and so let's say I've got 1 to 5. Well, that would be 2 to 10. That would be 3 to 15. That would be 4 to 20. So notice all of those, 20 divided by 4, 15 divided by 3, 10 divided by 2. But what happens, I would have to also start at 0, 0 for it to be proportional. So I would need to start at 0, 0, 5 to 1, and then 6, 7, 8, 9, 10. And then we would keep going, but this would be, it would be proportional. It does go through the origin. It is a straight line. And the data table as well is proportional, and it shows that it's going through the origin. So this is really fits the equation more of y equals kx instead of something that you're probably familiar with, is that y equals mx plus b. That was more of your middle level math, bumping into algebra. This one over here, y equals kx, the k represents your constant of proportionality. And the constant in this case, in this data table, was 5. 5 to 1 was the constant of proportionality. So here the table shows proportional relationship between the number of pounds of bananas purchased and the total cost of bananas. So in this case, which numbers of the pounds of bananas over here could be used as the missing values in the table? So you can use a calculator to model and to check this. You're taking $1.47 divided by 3. So that would be 49 cents. And I'll just write that down here. That would be 49 cents per 1 pound. If you take $2.45 and divide it by 5, you're going to get, again, 49 cents. $4.41 divided by 9. So you're going to get the same constant of proportionality as you go through the table. And it goes back to that unit rate, okay? So over here, you're just looking at, okay, well, what is 98 cents divided by 2? Is that going to be the same? Yep, that one works. That would be an answer, okay? What about $4.45 divided by 7? No, that's about 63 cents, so that one's not going to work. $2.94 divided by 6. That one works. That's 49 cents per pound of bananas. How about 54 cents divided by 1? Well, that's not the same as 49 divided by 1, so that's not going to work. And then if we had $3.92 divided by 8, that one's also going to represent 49. So these three would all be, if we were looking at putting values in the table, we could use any of those to fill into that table where we're talking about 2 bananas, 6 bananas, or 8 bananas. So we can also use proportions to help us continue ratio tables and whatnot. So if the price of gumballs is $15 and 25 gumballs is $15.50, Janie wants to buy 15 gumballs, what would she pay? Okay. So we could use a ratio table. And so this would be, maybe we'll say this is gumballs and this is the price. Okay. So we know that 25 gumballs at $15.50. And do that division, and we're going to see about $1.64, $1.65, if we're around that, approximately per one gumball. So finding the unit rate's helpful. If I wanted to use proportions, I could say, well, I've got $15.50 compared to 25 gumballs. I just want to know, well, how much would that be? I don't know. If I wanted 15 gumballs. Well, one thing you could do is you could do cross products. You could say 25 multiplied by X is 25X. $15.50 multiplied by 15 is $232.50. So you're doing this cross product. Divide that by 25 and you get about $9.30. Now that was asking for what? That was asking for 15. So I'm just going to scoot this one down and rewrite my ratio table and make that, what if I wanted 15 gumballs? What would that cost be? Well, that would be $9.30. So again, the price of 25 gumballs is 25 gumballs divided by, well, how much per gumball? 15.50 divided by 25, that's really a 62 cents there. Sorry about that. That's 62 cents per gumball. And I think I probably said that backwards and then typed it in the way I said it. So I apologize for that. So 15.50 divided by 25 gumballs. And that is about 62 cents, okay? So if I take 62 cents, of course, and multiply it by 15, I get the $9.30, which is what we found here. If I take the 62 cents and multiply it by the 25, notice I still get the 15.15. So I think I said one thing and wrote another. Apologize about that. But writing it as the 15.50 divided by 25 gumballs tells you how much per one gumball, which was 62 cents. So when we found that unit rate, that allowed us to then find, well, what if we wanted to find 5 gumballs? Okay, well, that would just be 62 cents times 5, and you're going to get $3.10. What if I wanted 50 gumballs? Well, I would take 62 cents and multiply it by 50, and it would be $31. So I'm using, again, I'm stressing the fact that I'm using the unit rate. And I'm also using the 25 gumballs, that was $15.50, that's what was given, to help me find the unit rate. And then I could use the ratio table, or I could use proportions to help me find what else it was asking. Was what if she wants to buy 15 gumballs, what's that going to cost? So that brings to a conclusion of proportional reasoning. And then the next video will be all things percents and different taxes and discounts and different percent problems.